Can you start by telling us who you are and what you do?
Sure, my name's Conor O Neill. I'm the Chief Product Officer with NearForm, so handle all products and sort of productization initiatives inside the company.
And so one of the really fun things about NodeConf EU this year is that we have some really unique badges for attendees. And I understand that you were kind of the main shepherd for this project. Can you start by just giving a quick overview of what these badges are?
Sure, these badges are a follow-on from what we did last year. They basically are Bluetooth low energy badges. They run a JavaScript interpreter called Espruino, and they do lots of fun things. They did lots of fun things last year, but this year, more importantly, we decided we wanted to connect them to the internet and get useful things out of them and send useful things to them. So that was the overarching aim of what we wanted to do.
Yeah, I think it's a really great solution, and it's been really fun seeing attendees play with them. And it's also, from what I understand, a really almost like classic IoT scenario. Can you talk a lot about kind of the more back-end side, the internet, the I part of IoT, and how that plays out in these badges?
Sure. So, as I said, let's talk about sort of the outbound direction for what's going on. So the badges are broadcasting over Bluetooth. They're sending few pieces of information. It's all opt-in for people don't want to do it. They don't have to do it, obviously. But it's sending a temperature that it's detecting. We have a simple clapometer feature, detecting claps or motion. All that information is getting broadcast all of the time, and then it's simply advertising that it exists. So every badge in the place is doing this. Then we basically have 20 Raspberry Pis scattered around the hotel, more dense in the more dense areas. They also have Bluetooth, they have Wi-Fi, and they're picking up all of these broadcasts from all of these badges. They're taking that, basically running node code that we wrote. That node code is built on top of the Microsoft Azure libraries. Funnily enough, the Microsoft Azure libraries, the MQTT ones anyway, are built on top of MQTT.js, written by our very own Matteo Collina. So there's a nice dog fooding aspect to the whole thing there, which initially we didn't realize. We'd written the code and then we realized we were dog fooding. Those libraries they're basically taking all that information and sending it over MQTT to Azure, and kind of the first point of contact then is Azure IoT Hub. So it's taking all of this data. We estimated on Monday we hit about 400,000 messages. Yesterday about the same. I haven't checked today. Today's Wednesday. We haven't checked on day 3, but about that. So 400,000 MQTT messages going into IoT Hub, and then the original spec was let's do some stuff with that.
Very official.
Yes, we were very good. We worked from that. Okay, stuff. What stuff can we do with that? And actually, one of the things they do is what's in Azure that we can use. So one of the aspects of this was our DevOps guys know Azure inside out. So they know how to deploy anything you want onto Azure, particularly things like AKS. Like they're one of the very first groups to deploy production code onto AKS. But as developers on the development side of the house, we hadn't used a lot of the more advanced features. Everybody's used to VMs and containers and all that sort of stuff, but not the actual kind of value add features. So we started kind of poking around in there, tried certain things, saw how different things tied together. So we ended up using from sort of IoT Hub, we had Stream Analytics then, kind of crunching down a lot of that data. We persisted everything into Cosmos DB, all of it anonymized. That was really important to us. So there's no way of in any way knowing who had what badge and where they were or anything like that, but persisted all that data, crunching with Stream Analytics, and then doing a few things with Event Hub and Event Grid. And the eventual output from that direction was we have a giant screen downstairs showing a heat map of the event, so you can see where are the busy places, where are the less so busy places in real time. There was two aspects of that. One, it's fun. It's just here's a useful implementation, but also if you suffer from social anxiety and you're not comfortable where the big crowds are, you could actually use the map to actually say, okay, I'm going to stay away from there. And even simple things like the restaurant looks really busy right now. I'm going to wait a while until that colour comes down before I go and get my lunch. So we wanted to do that. And then on the clapometer side of things, that was pure fun. There is no way we're going to be sending people, your report on your stock, this year was 4,000 claps, a little bit less than the person who went before you. We're not doing that. It's just pure fun, but it's also, how do we crunch down that data? How do we actually do the stuff in real time? So that is, again, that's a real-time feed from the various rooms showing the kind of the general level of, we'll say, abrupt movement rather than claps. So we got as far as abrupt movement. So that's kind of in that direction. Some of the post-processing we want to do after the event is things like, it'd be really nice if we could do replays of the claps over time, the heat map moving around, a time lapse of the heat map moving around, over the 3 days as it went in and out and people went in and out. So we think we can do some fun stuff there. And then, so that's sort of side one of it. So that's pulling stuff out. And as you say, classic model, very, very low powered devices. Similar devices to this, I was running at home and sort of the test rig for a lot of this, and they were running for weeks off a single battery because they didn't have a display. All they're doing is just pinging out, little messages. Then you're going to your gateway devices. I suppose in a traditional IoT model, that's some giant, big sort of rack-mounted thing running Java Enterprise, rather than $20, $35 computers scattered around an event and not breaking a sweat, sending 400,000 messages a day, to a big back end to something like Azure where you can do something interesting. Then in the other direction, I suppose the other thing we did that I was also involved in was we did the progressive web app for the event. So that was, again, an upskilling exercise for some of our guys. They were back-end developers. They wanted to learn more about front-end, and we used this as a way for them to actually figure out how to upskill on React. We built out the team then. We went, actually, there's something in this. This is not just fun. It's really useful. It's a really good learning exercise. We brought in, we had a couple of guys in a short period in between projects, front-end guys, like our really, really high-end front-end guys, who then showed this is the absolute best way to do this using, at the absolute cutting edge of what you can do front-end wise with React and the latest on PWAs. So we did all of that. That had a back end running in Azure. In their case, they're running CouchDB for their backend, so that's running in Kubernetes pod in AKS, and then we connected to that. So we were then monitoring its backend for all the schedule information, including changes and so on. So we had a whole bunch of, actually the other aspect of Azure, we were using a whole pile of functional apps then running on cron jobs and so on, monitoring the event information, and then going in the opposite direction and back out via IoT Hub to the Raspberry Pis, to the badges saying what's on now, what's on next. And then we built an entire alert system around that as well, where as an admin on our PWA, I can send an alert that goes to everybody in the app who has the app installed or the PWA installed, and it goes to anybody with the badge who is. I'm trying to create a new phrase. It hasn't actually caught on at all this week. It's called Bluetooth coverage. Everybody talks about Wi-Fi coverage. I want to create Bluetooth coverage. So if you were within Bluetooth coverage of the event, you got an alert on the thing. And the idea there was, we're all overloaded with phone notifications. I ignore my phone most of the time when it buzzes. Whereas with the badge, we've only been sending 2 to 3 a day. So if the badge starts buzzing and flashing red, it's probably important or germane to right now. So we've been sending sort of lunch notifications, bus leaving notifications, that kind of thing, and that's all worked very, very well. But that, again, it was just another thread through the various features of Azure that we were able to take advantage of to do all of that. And that's another one of those things that we didn't know in a lot of these cases until we got here. To be brutally honest, we didn't know what's going to happen with 300-ish badges, 20 Raspberry Pis, and Azure. Well, let's just turn them all on and see. And we had a few small glitches on day one when you had 300 badges all within 3 square meters of each other. But actually it works, and every single bit of it, scalability wise, there's just been no issues at all. Classic Wi-Fi issues that you often get in an event, but it sailed through all of those. So it was a learning experience, but there's a lot of stuff we want to be able to talk about. We're going to be writing a lot about this, particularly on the various architectures inside Azure. We tried some approaches that didn't work, so we want to let people know, this worked for us, this didn't work so well. We found this very efficient. We've already been doing a lot of writing. Our DevOps guys have been talking a lot about, for example, switching from Circle to the new DevOps features in Azure. We've been using some of that, and now we want to switch over to sort of the application side of things and say, right, okay, you've got all this stuff again. How do you use it, and how do you use it efficiently? So that's me talking non-stop for about 6 or 7 minutes.
Well, I mean, there's certainly a lot to talk about. This is a large, complicated app, and it has many, many different features to it. And one thing I noticed that you kept saying, bringing up over and over, is just the scale of this. And this is definitely one of the big challenges that we have in IoT, or that IoT brings to more classical computing models. It's just the scale of things. There's so much more data involved with sensors and things like that. And so the ability to scale is even more important in IoT than I think in other areas. And of course, scaling is also one of these things that's been sort of the promised land of cloud computing for a long time. Yes. But I feel like but for a long time, it's been that promised land, we've never quite gotten there. Based on your experience with Azure though, and with some of the newest features, and you're using a lot of very new features in Azure, do you think we finally kind of gotten to that point?
I'm actually going to say yes, because I was talking to Gordon Williams, who designed the badge earlier on, and we were just standing there going, it all just worked. And we didn't have to, so take something like IoT Hub. We went in knowing nothing about it. We weren't even sure, is there persistence in there? How does it actually work? It's sort of, with some sort of pub something, we'll figure it out. And no tuning, no tweaking, no how do we configure this to do that, no how do we configure that. It's like, there's Cosmos, dump stuff in there. There's IoT Hub, configure one. This is your connection, literally, here's 20 connection strings for 20 Raspberry Pis. You're done. Stream it in, and never have to think about it again. Just keep streaming that stuff in, and at the back end then we have our functional apps, we have Stream Analytics. The Stream Analytics stuff, some fairly straightforward queries happening there, just pulling on that data. At no point did we ever, from a cloud perspective, did we ever have to think about scale or infrastructure, or, it is actually, we talk about, for example, if you look at that progression that's happened, bare metal, the VM, that 20-year arc, I remember when VMware came out, that arc from, as I said, and then to containers, and now to serverless, and now to effectively just this scalable infrastructure that we can just take advantage of. And you pay your bill based on how much you're using, and it scales up and it scales down, and we never have to think about it. And then from our own perspective, the only thing we had to think about in terms of scale was literally the number of badges in a particular, the number of devices, if you just make it a generic thing, in a particular location. How much coverage did we need to actually be able to extract all that information out? But once it hit the edge, we were done. We never had to worry. It just flowed out. And now that it's all persisted, so we've done all the real-time aspect, because it's all been persisted, we can do that sort of replay stuff. And again, we don't have to think about it. There's no building out of anything. Somebody's just going to sit down and use either some built-in features of Azure, some of the more the analytical features of Azure, or build a web app to pull out this data and show it again. We're at a moment, I think, that we were able to do this. I won't say going in blind, because obviously we did a lot with the badges last year. We knew what was going on around data. Node, or NearForm, we know Node inside out, but the fact that there was never a question, even on the edges, do we have enough performance here? It was never a question. It was simply, as I said, 400,000 messages a day isn't, in this overall scheme of things, isn't a gigantic number per second, but it's still it's a pretty decent number of messages per second to be going out with dirt cheap consumer level devices. And there's something in that as well. When you think about, these badges and the silicon they're using and how cheap it is per unit. These are things that are going into Fitbits and so on. You're looking at Raspberry Pis that are almost at the disposable level computers that, you know, anything goes wrong with a Pi, throw it out, stick in another one. And then you have this, I'll call it infinitely scalable infrastructure behind it. Our lives are just so easy. They really, really are. And that's fantastic. And it means that we could go from a month ago having almost none of this to being in production on Sunday evening. And CapEx, what CapEx? So there's something to be thought about there for people, I think, particularly doing industrial IoT. When you think about the cost of industrial IoT in general, now obviously there's reliability, there's compliance, and there's all those other issues we never had to think about, but in terms of the price point, the cost point, and being able to scale as organizations, we're at an inflection point there, I think, in all this stuff.
All right, thank you so much for joining us. This was a great chat.
Brilliant. Thanks very much.